Example 5. The question says, what is the amount in mole? You can see again, we are asked amount in mole of sodium carbonate in 5.3 grams of the compound. So we are given sodium carbonate. Sodium carbonate is Na2CO3, and we are simply asked what is the amount in mole of calcium or sodium carbonate in a given quantity of it, and that quantity is 5.3 grams. So what do we simply do? This is an equation that doesn't require any reaction or equations per se. It is a question that doesn't require any equation because it is just a single species, and they are asking for the number of moles of sodium carbonate. Sodium carbonate is not reacting with anything, it is just by itself. They provided us with 5.3 grams of sodium carbonate. Sodium carbonate. We are provided with 5.3 grams of sodium carbonate, and we are asked to say what is the amount in mole of that mass. In other words, you are given, for example, you are given 25,000 naira. You are given 25,000. You're provided with 25,000 naira, and you are asked what is the value of 25,000 naira in dollars. That is just the question. 5.3 grams of sodium carbonate was provided, and you are asked what is the amount in mole, no more in grams. So they just want you to convert the 5.3 grams to mole. That's just a simple question. So it's just like you are having 25,000 naira and you are asked what is the value of 25,000 naira in dollars? What is its equivalent in dollars? That is just a simple question. So what do we do? So to solve that question is simple. You have to bring out your parameters, and we have already done that. 5.3 grams of the salt is given to us. So what is the amount? N is what we are looking for in mole. We don't know. So what we need to simply do is check for how to relate amount, that is N, that is the mole, to mass. What's the relationship between mole and mass? The relationship between mole and mass is N is equals to mass over molar mass. That is the relationship. So that's the four relationships of mole with other parameters is very, very important. So always remember those relationships as we have seen here. That is to say, these relationships are very, very important for us to always remember at any point in time. When you're given any question, always try to remember this relationship. That is, any question that has to do with mole and other parameters, whether volume, concentration, mass, molar mass, let's remember this relationship of mole and other parameters. They will go a long way to help you understanding how to solve any question whatsoever. So the relationship between mass and mole is N equals M over mm. So what do? Sodium carbonate is the species here. No other species with sodium carbonate. And sodium carbonate is, the formula is Na2CO3. So what we simply need to do is N is equal to mass of sodium carbonate, which is 5.3 over molar mass of sodium carbonate. Molar mass of Na2CO3. And what is the molar mass? We are going to do it now. N is equal to 5.3 over the molar mass of sodium carbonate can be calculated easily. We have seen that before. Sodium is 23, carbon is 12, and oxygen is 16. So let us take a look at how to do that. Sodium is 23. The relative atomic mass of sodium is 23. but there are 2 sodium atoms there, so it's going to be 23 times 2 plus the relative atomic mass of carbon is 12, so we're going to put it, there's 1 carbon there, so that is 12. Then plus the relative atomic mass of oxygen is 16, but there are 3 oxygen atoms there, so that's going to be 16 times 3. So this is N is equal to 5.3 all over 23 times 2 is 46 plus 12 plus 16 times 3 is 48. So that gives us 5.3 divided by 46 plus 12 plus 48. That gives us 106. So our final answer therefore will be 5.3 divide 106. 5.3 divide 106, that gives us 0.05 moles. So that is our answer. And it's as simple as that. So what it simply means is that 5.3 grams is equivalent to 0.05 moles of sodium carbonate. 5.3 grams of that salt is equivalent to 0.05 moles. That is just what it implies. Okay. Away from that, let us take a look at our next example. The question says, the fermentation of glucose to ethanol occurs by the reaction 66H12O6 goes to 2 moles of ethanol. Ethanol is C2H5OH plus 2 moles of carbon dioxide. And that reaction is being facilitated by yeast. Yeast acts as an enzyme, making the reaction to proceed. So let us take a look at what we need to do. Now the question says, how much ethanol will be produced from 1 kg of glucose? And in brackets, we have been provided with the relative atomic masses of the elements involved. So we need to understand the question. From understanding the question, you will get to solving the problem, even without thinking twice. So the question simply says again, the fermentation of glucose, that is to say, glucose, which is 6H12O6, will go to ethanol by the reaction, as we can see on the board. And the question simply says, how much ethanol are we going to get from 1 kg of glucose? It is worthy to note that for this type of reactions, we don't solve in kilograms, but we have to take it to grams. So that is the first thing you need to understand. So, simply put, let us take a look at our equation. So, we have this now. We have our glucose C6H12O6. When glucose is fermented, we have 2 moles of ethanol, C2H5OH, and of course, CO2 giving up. So, what do we need to do? And we are told that yeast facilitated that reaction. So, yeast is acting as an enzyme. Now, from the question, we are told that 1 kg of glucose is involved. 1 kg of glucose is involved. But we need to convert this to grams, as we don't work with kg in this type of questions, except you are being told to do so. So 1 kg is equivalent to 1,000 grams. So simply put, 1,000 grams of glucose is being provided. And we are asked, how much ethanol are we going to get from 1,000 grams of glucose? That is the simple question. So what we need to do is, first of all, we'll check for balanced equation. Is the equation balanced? That's the first question. Yes, looking at the equation, it is balanced. As we can see, it is absolutely balanced. Carbon is 6 at the left-hand side. Carbon is 6 at the left-hand side. And at the right-hand side, carbon is 6. 2 times 2, 4, and there is another 2 here. That is 6. Hydrogen is 12 at the left-hand side. And at the right-hand side, hydrogen is 2 times 5, 10, and another 2 times 1, 2. So hydrogen is balanced. 10 plus 2, 12. Sorry, this is hydrogen, not carbon. Hydrogen. Oxygen is 6 at the left-hand side, and oxygen is also 6 at the right-hand side. How? Oxygen is 2 times 1, 2, and there is another oxygen here, 2 times 2, 4. So we have 4 and another 2. So oxygen is balanced. 6 here, 6 there. 12 here, 12 here. 6 here, 6 there. So the equation is absolutely balanced. I just want to clear you because I know some students may be saying, how can we balance the equation? Is it balanced? Okay, the equation is absolutely balanced. Now let us take a look at how to go about solving our question. Since we've seen that the equation is balanced, the next we ought to do is to simply calculate their molar masses. And the molar mass of the individual species has been given to us. Notwithstanding, by this time, I want to believe, dear students, that you should be familiar with the relative atomic masses of these simple elements: carbon, hydrogen, oxygen. You should be familiar with them by now. Everyone should know that carbon is 12, oxygen is 16, hydrogen is 1. So for simple elements like this, by now you should be familiar with their relative atomic masses, and even for other elements. So let us take a look at what we have. Now, calculating their relative molecular masses, carbon is 12, but there are 6 atoms of carbon there. So we have 12 times 6. Plus, hydrogen is 1, but there are 12 atoms of hydrogen there. So we are going to have 1 times 12. Oxygen is 16, but there are 6 oxygen atoms. So that gives us 16 times 6. And we are having ethanol. So ethanol is 2 moles of ethanol. So this is going to be 2 outside bracket, because the question is interested in glucose and ethanol. Carbon dioxide is not really needed. So we have, there are 2 atoms of carbon, and carbon is 12. So it is going to be 12 times 2. Plus, we have 5 atoms of hydrogen, and hydrogen is 1 times 5. Plus 1 oxygen, 16. And then plus another hydrogen, 1. So we have it like that. Now 12 times 6. So 12 times 6 is 72. That gives us 72. Plus 1 times 12 is 12. Plus 16 times 6 is 96. And this is against 2 into 12 times 2 is 24. Plus 1 times 5 is 5. Plus 16 plus 1. So we have the summation 72 plus 12 plus 96. What will that give to us? Let us take a look at what that gives to us. It gives us a total of 180. Let's have this. So we have a total of 180. 180. Sorry about that. Let us make it clearer. Make that clearer. So we have 180. So 180 grams of glucose from our equation will give us 2 into 24 plus 5 plus 6 plus 1. That gives us 44. That gives us 44. That gives us 44. So we have to multiply 44 by 2. Oh, sorry, that's not 44. That's going to be 46. That's going to be 46. So we have it that we have 46. So 46 times 2, that gives us 92. So we have 180 grams of glucose giving us 92 grams of ethanol. So from the equation, 180 grams of glucose will give 92 grams of ethanol. So what we simply have to do is, from the equation, if 180 grams of glucose produces 92 grams of ethanol, then 1000 grams of glucose will produce X. Because the question says, how much ethanol will be produced from 1 kg of glucose? And 1 kg of glucose is 1000 grams. So since all other species are always calculated in grams, we also have to take the glucose to grams. Others cannot be in grams, while glucose will be in kilograms. So we have to make all units to be the same. And that is why we have to convert glucose to grams. 1 kg is equivalent to 1000 grams. So if 180 gives us 92 grams of ethanol, then 1000 grams of glucose will give what? X. We don't know. So let's cross multiply. Cross multiplying now, we have 180 times X is equal to 92 times 1000. And we have 180X is equal to 92,000. So to do that, we have dividing both sides by 180, and that gives us 180 can take care of 180. Therefore, our X is equal to 92,000 divided 180. That gives us 511.11 grams. And to a whole number, X is 511 grams. So 511 grams of ethanol. 511 grams of ethanol will be produced from 1000 grams of glucose when it ferments. So this is actually how to calculate any given question at all under stoichiometry. I want to believe, dear students, that it is very clear now. So it's our answer.